In example 2, we're going to find the particular solution to this differential equation. The very first step to do that is to separate the variables. So we're going to want to get dx over to the right-hand side. We're going to do that by multiplying each side by dx. So the dx's on the left will cancel. We'll have dy is equal to, and then I've got this whole mess over here, 1 plus 12x to the 3 halves power in the numerator. In the bottom, I'm going to change this to 2, and then I'm going to make that an x to the 1 half. So we'll change that square root of x into x to the 1 half. And then our dx is on the right-hand side. No y's are on the right-hand side, so we don't have to move those over. We're going to need to integrate each side here. If you want, you can put y to the 0 power here to help you out, or a 1, that would work too. And we're going to integrate the right-hand side as well. To integrate the left-hand side, the antiderivative of y to the 0, or 1, is just y. In other words, y has a derivative of y to the 0 power. On the right-hand side, things are a little bit trickier, so we're going to have to do a little bit of division with each part of the numerator. So we're going to look at the 1, and we're going to look at the 12x to the 3 halves power. We're going to divide that by 2x to the 1 half. So here, I'm going to have 1 half times x to the negative 1 half power. If I move that x to the negative, or x to the 1 half up, it becomes x to the negative 1 half. Then I'm going to take 12x to the 3 halves and divide it by 2x to the 1 half. So 12 divided by 2 is 6. X to the 3 halves divided by x to the 1 half. Remember your exponent rules, you're going to subtract those exponents. So that's 3 halves minus a half is 2 halves, or 1. So that'll be just 6x. And now we have a polynomial-like function. So we're going to go ahead and be able to find the antiderivative of that right-hand side. If we use our power rule in reverse, we're going to do 1 half. And then we're going to add 1 to the exponent of x, which is negative 1 half plus 1 is a half. And then we're going to divide by that new exponent. So if we divide by that new exponent, that's the same as multiplying by 2. So we're going to take this guy right here, and dividing by 1 half, once again, is the same as multiplying by 2. Then we're going to do the antiderivative of 6x, which is going to be 3x squared, and of course plus c. Simplifying a little bit, the 1 half and the 2 will cancel, leaving us with x to the 1 half plus 3x squared plus c. At this point, what we want to do is we want to try to find that value of c using our initial condition, which is right here. So f at 0 is 2, meaning the y value is 2. We'll do 0 to the 1 half plus 3 times 0 squared plus c. Well, 0 to the 1 half is 0, and 3 times 0 squared is also 0, so we find c to be 2 here. Then we're going to go right from our general solution, which is this one with the c, and all we're going to do here is we're going to replace that value of c. And you can make the x to the 1 half square root of x. Sometimes you'll see it like that for sure. And then the 3x squared is going to stay the same. And then we've got plus 2. This one's already solved for y, so we kind of lucked out there. We don't have to do any extra solving work right here. So that is the particular solution to the above differential equation, once again with this initial condition.